Okay, we're doing the interest applications problem. Nope, I just about went past it. Where is it? Here we go. In this application, we're going to use Excel to solve the problems of future value, present value, and things like that. So let's get started here. First thing you have to do is put your name in it. Okay, we're going to calculate simple and interest for part of the year, calculate compound interest, maturity value, ordinary and exact interest, and then amortization. Della Jacobs borrows $1,200 for 1 year at 10%, so she should have about $120 worth of interest. Let's see if we can use Excel to figure that out. Principal, $1,200, rate 0.1, that's 10%, time 1 year. The interest, you find it by typing equals, you see it right here, equals future value, because we're looking for the future value, oops, equals future, just wait. I gotta unprotect this sheet. Okay. Or this cell. Okay, the future value, so equals future value, and the rate is this number. The number of periods is 1 year. Oops, we got some more work to do. There is no payment, and the present value is the $1,200. So at the end of a year, you will have $1,320. Oh, we should have made this one negative 1,200. Oops, I didn't do that right. Negative $1,200. There we go. And so the interest is this amount, the future value, subtract the principal or present value. Next one. So we have $1,200, $12,800 at 7% for 2.5 years. So the future value, we would just do interest. The future value will be the principal times the rate times the time, and this should say interest. Okay, next one. Francis Koo is planning to start a business that will export American food to China. He estimates he will need $50,000 for organizational costs. He can borrow the money from his relatives for 3 years, and they want to pay 10% ordinary interest. So $50,000 at 10%, which is 0.1, for 3 years. The interest will be the principal times the rate times the time, and then the total amount owed will be the interest plus the principal. $8 million at 9% for 90 days. Let's say $100,000. I don't know if that's right or not. That's probably a little bit much. $10,000. How does that sound? Well, we'd take $8 million times 0.09 for just a second. I don't know what's going on here. I had to change the color scheme for some reason. The time is 90 out of 365, and the interest well, let's try just 90. So the interest is the principal times the rate times the time divided by 365 gives us $177,000. Okay. Ordinary interest has 360 as the denominator, so find the ordinary interest on $625, and the rate is 0.081. The time is 60 days, so the principal times the rate times the time divided by 360, because it's ordinary interest, is $8.44. Charles Peterson, managing partner of a local transportation company, thinks the company should borrow money to upgrade its truck repair facility. Let's see how that would work for them. They need $250,000 at 0.075 for 180 days. So the interest will be the principal times the rate times the time divided by, and it says exact, which would be 365 days. Okay, next one. Oh, the total amount they will have to pay back is $250,000 plus the $9,246. Next one. Steve Teeter took out a loan for $3,500 at Fortune Bank for 270 days. If they used ordinary interest, what rate of interest was charged? If the amount of interest was $269, the principal is $3,500, and it's 270 days. We're looking for the rate. So the rate is the interest divided by the principal times the time divided by 360 days. So it's 10.2% interest. Okay, Marie Stewart invests $3,000 at 6% compounded quarterly. The formula equals future value. So the number of periods, in 1 year she will have 4 quarters. The rate is 0.06. The interest per period is the nominal rate divided by 4 because she's going to pay it quarterly. And the principal is $3,000. The maturity value, according to the formula, is equals future value of the rate, 1.5%, times the number of payments, 4, times the payment, which is 0, times the present value, which is that. If it's in red, we have to make it come out to be negative principal, $3,184. So the interest will be the maturity value, subtract the principal, and you get $184.10. Use the formula. The rate is the amount of interest, which is 100 184.10 divided by the principal, 3,000, times the time, 1 year, and we get, whoa, $184.10 divided by the principal times the time, and we get 6.14%. Okay, how much will Marie's investment be worth in 6 years? So the compounding periods instead of 4 will be 4 times 6, or 24. The nominal rate is 6%. The interest per period is 1.5%. The principal is $3,000. So the maturity value will be future value of the rate times the number of periods, and there's no payment, and the present value is negative this, and we get $4,288.51. Now there's two different things happening, the First National Bank and the Second National Bank. The First National Bank is compounded quarterly, so that's 4 periods per year. The Second National Bank is just 1 period per year. The nominal rate here is 0.04. The nominal rate here is 0.05. The interest per period is 0.01 because it's 4 divided by 4. And this one would be just 5%. Number of periods, there's 4 in a year. There's only 1 in a year. The principal is $8,000 in both cases. The maturity value is the future value of the rate, the number of periods, the payment, which is 0, and make sure you put in a negative sign to get the principal rate, and we get $324.80. Oh, it's for 6 years. So in this case, it's 24, and in this case, it's 6. There we go. Now we got it right. Now I'm going to just copy this formula and put it over here, and you can see that the Second National Bank gives you a little bit more interest. Now it says go to page loan amortization to finish the rest of the problems. Christina Balmori purchased a condominium for $188,000. She made a 20% down payment. So how much did she finance? It's $188,000 times 0.80. Since she made a 20% down payment, she's financing 80%. Okay? So we have rate, D for down payment, financed, and total. The price. Okay, here we go. The 100% was the price, and 188,000 was the amount financed. The financed rate was 80% since she financed, or she made a 20% down payment. So this cell will be cross multiply 80 times 188 divided by 100%, and we get $150,400. So now let's fill in the amount, 1,000. So 1,000 or $150,400, and it's a 30-year mortgage at 0.059. Loan period in years is 30 years, 12 payments per year, and the start date is now, so I'm going to type now. And Her payments are $892.08, and she pays $170,747.83 in interest. If you are done, your score will be 30 out of 30, and so you can see that you have completed the project. Save it and submit it.